Welcome everyone. Today, we're tackling one of the most controversial questions in recent years. Is the Earth flat or round? Yes, it's a topic that sparked heated debates and endless theories. Joining me today are two guests with very different views. We have Dr. Rachel, an astrophysicist who's here to defend the round Earth model, and Tom, who believes the evidence points to a flat Earth. Rachel, let's start with you. What makes you so certain the Earth is round?
Thanks, Max. For me, this isn't just theory. It's science we've tested over centuries. We know the Earth is round thanks to astronomical observations, gravity, and even photos from space. If you look up, you'll notice other planets, like Mars and Jupiter, are round due to gravity pulling mass into a sphere. The Earth's shadow during a lunar eclipse is also round, which wouldn't happen if the Earth were flat. And we have images from space taken by satellites and astronauts showing a perfectly round Earth. This is all solid evidence. There's just no question. The Earth is a globe.
Interesting points, Rachel. Tom, let's hear your take. You believe the Earth is flat. What evidence led you to this conclusion?
Thanks, Max. I know Rachel brought out the big guns with science, but here's the thing. Most of us experience the world in a way that feels flat. When you stand outside, the horizon looks perfectly level, no curve in sight. And Max, think about flights. If the Earth were truly round, wouldn't pilots have to constantly adjust the plane's altitude to avoid flying off into space? It sounds funny, but we don't feel any of that. And those space photos, many of us believe they're heavily edited or even fake. There's so much more that makes me question the mainstream model.
Okay, Tom, you're saying the horizon looks flat and pilots don't adjust for curvature. But Rachel, let's challenge that. Do these observations hold up scientifically?
Max, I understand why it looks flat to us from ground level. That's just how perspective works. But when you get high enough, say from a plane at 35,000 feet, the curvature actually becomes visible. You can even see it on high-altitude balloon videos. And Tom, as for pilots not adjusting, that's because gravity does the work. Gravity keeps us in orbit around the Earth, so pilots don't have to constantly adjust to curve around. They're naturally flying around the globe without thinking about it.
But Rachel, that's the thing. Gravity is just a theory, an explanation. And besides, I've seen experiments where people have measured long stretches of water or land with no measurable curve. Some people have used laser beams across lakes to show that if there were a curve, the laser should disappear. But it doesn't. To me, that shows the Earth is flat, or at least not as curved as we're told.
Laser beams across lakes? That's a new one for me, Tom. Rachel, what do you say to that? If the Earth is round, shouldn't we see a curve in these kinds of experiments?
Great question, Max. Tom, I've heard of these experiments, but they often don't account for refraction. That's the bending of light over long distances, especially over water. It's why a ship appears to sink as it moves away on the ocean. It's actually moving over the horizon, but the light makes it appear higher up. Also, the Earth's curvature becomes more noticeable over greater distances. So these small-scale tests can be misleading if we don't consider atmospheric effects. When scientists do these measurements correctly, the curvature shows up as expected.
I hear you, Rachel, but it still doesn't add up for me. You're saying all of this relies on things we can't see, like gravity and refraction. But isn't science supposed to be about observation? I see a flat horizon, and I've never felt like I'm spinning. Doesn't it make sense that we experience the world this way because it is flat?
Good points on both sides. Rachel, Tom's challenging the idea that we should trust things we can't directly observe. How does science answer that?
Science is all about observation, but it's also about evidence that comes together to explain what we see. Take the fact that different constellations are visible from the northern and southern hemispheres. This only makes sense if we're on a round Earth. Or consider time zones. The sun rises and sets at different times around the world. A flat Earth model doesn't explain these observations without bending over backward. Science isn't asking for blind trust. It's just about piecing together the evidence that fits best.
All right, this is shaping up to be an epic debate. Rachel says evidence like constellations, gravity, and refraction show a round Earth, while Tom argues that the world we experience is clearly flat. But we'll get into the nitty-gritty, exploring more evidence and challenging each side with new questions. Stay tuned. Whether you're a firm believer in a round Earth or you're open to other theories, you won't want to miss what's coming next. We'll see you soon with more arguments, counterpoints, and even some surprising twists. We heard why Dr. Rachel believes the Earth is round and why Tom sees it as flat. Now, it's time to dig deeper. We're getting into the evidence and hearing each side address specific claims. Rachel, let's start with you. Tom mentioned that when we look at the horizon, it seems perfectly flat. How does science explain that?
That's a great question, Max. And it's a common point of confusion. The reason the horizon looks flat is perspective. When we're on the ground, we can only see a short distance compared to the Earth's full size. Think of an ant on a basketball. It's too small to see the curve. But as you go higher, the curve becomes visible. That's why astronauts in space and high-altitude photos show the Earth as a clear curve. The horizon only looks flat because we're so close to it.
Tom, Rachel says the flat horizon is a matter of perspective. What's your response? Do you believe there's more to it than that?
Max, I get the perspective argument, but I think there's more to it. If the Earth were truly round, we'd see evidence of the curve all the time, not just from space. And Rachel, if we're on a spinning ball, shouldn't we feel some sense of motion? But the Earth feels solid and stable. To me, that's evidence against a round Earth. It doesn't feel like we're moving at all.
Interesting point, Tom. Rachel, how does science explain why we don't feel the Earth spinning?
That's a great question, Max. The Earth is spinning at about 1,000 miles per hour, but it's a smooth, constant speed, like riding in a plane at cruising altitude. If you're moving steadily, you don't feel the motion because there's no change in speed or direction. Plus, Earth's atmosphere moves with us, so we're essentially in sync with it. That's why we don't feel like we're spinning or moving.
I hear you, Rachel, but to me that's still a theory. It doesn't match what we actually experience. And let's talk about water. If the Earth is round, how does water stay curved on the surface? Water always seeks a flat level. Shouldn't it spill off if we're on a sphere?
Good question, Tom. Rachel, can you explain why water stays on a round Earth?
Absolutely, Max. This comes down to gravity. Gravity pulls everything, including water, toward the Earth's center. So, on a round Earth, water conforms to the surface because it's being pulled equally from all directions toward the center of mass. Think of gravity like a force that keeps water stuck to the Earth. That's why oceans and lakes follow the curve of the Earth. Without gravity, water would indeed just float away into space.
But Rachel, gravity is still a theory. No one can see or feel it. And if gravity is so strong that it keeps oceans and everything else in place, how come small insects and dust particles can just float away? Gravity seems selective when it suits the round Earth model, but it doesn't apply equally in every case. To me, that raises questions.
Rachel, that's an interesting question. Why do things like dust particles float while gravity holds oceans down? Can you clarify that?
Great point, Max. Gravity does apply to everything, but its effect depends on mass. The larger the mass, the stronger the pull of gravity. So, while gravity keeps heavy oceans in place, small particles like dust don't have much mass, meaning they're barely affected by gravity. That's why you can easily blow dust away or see insects floating. But the effect of gravity on massive objects, like oceans or mountains, is very clear.
All right, we've covered a lot. Rachel, you say gravity and perspective explain the round Earth, while Tom argues that direct observation points to a flat Earth. Before we wrap up this section, I'd like to hear your final evidence. Tom, let's start with you. Is there one piece of evidence that you think proves the Earth is flat?
Yes, Max. One of the strongest pieces of evidence for me is the Antarctic ice wall. According to many flat Earth theories, Antarctica isn't a continent at the bottom of the globe, but a massive ice wall surrounding the flat Earth, holding the oceans in place. If this wall exists, then we're not on a round Earth at all, but rather on a flat plane with boundaries. The lack of exploration around it raises serious questions.
Rachel, that's an interesting theory. How do you respond to the idea of an Antarctic ice wall?
Max, I understand where that theory comes from, but Antarctica has been extensively mapped and explored. Scientists have crossed it, there are research stations, and even tourists visit. If there were an ice wall around the Earth, we'd have plenty of evidence. What we actually find is a landmass at the bottom of the globe that aligns with the round Earth model. To me, the existence of Antarctica as a continent supports the globe model, not a flat Earth.
Fascinating. So, we've got Rachel relying on scientific exploration and physics, and Tom leaning on direct observation and some intriguing theories. Next, we'll dive into the practical implications of these beliefs. Whether you're on the round side, the flat side, or still on the fence, you won't want to miss what's next. We've discussed the evidence, the theories, and even some surprising twists. Now, let's tackle the big question. Why does it matter? How do our beliefs about the shape of the Earth impact our lives? Rachel, let's start with you. Why do you think it's important for people to accept the round Earth model?
Thanks, Max. I believe understanding that the Earth is round is essential for many aspects of science, navigation, and technology. Things like GPS, satellite communications, and even air travel are built on the concept of a round Earth. If we denied that model, we'd have to rethink so many systems we rely on daily. And beyond technology, I think it's also about trusting evidence-based science. The round Earth model isn't just a theory, it's something we've tested, measured, and confirmed for centuries.
Tom, Rachel argues that believing in a round Earth supports everything from navigation to technology. But what about the flat Earth model? Why do you think this perspective matters?
Max, for me, this isn't just about the Earth's shape. It's about questioning everything we're told. Believing in a flat Earth is a way of challenging mainstream science, media, and even education systems. I think people should be encouraged to think for themselves, to look at the world around them, and ask if what they see matches what they're told. The idea of a flat Earth is about taking control of our understanding and being open to possibilities beyond the accepted narrative.
So, Tom, you see the flat Earth view as a way of thinking independently. But Rachel, what do you think about this idea of challenging mainstream views? Do you see any value in questioning scientific models?
Absolutely, Max. Science itself is about asking questions. Challenging established ideas has led to countless discoveries throughout history. But there's a difference between skepticism that pushes science forward and denying evidence that's been tested repeatedly. For example, the round Earth model isn't just something scientists decided. It's something we've confirmed through observations, experiments, and even space exploration. Skepticism is healthy, but we need to build on what we've proven to keep progressing.
Rachel, I appreciate that, but I still think there's too much trust placed in things we can't see ourselves. The average person can't go to space to verify this, so we're left trusting others. And if people feel uncertain, I think they have every right to question what they're told. It's about keeping our minds open and not just accepting everything at face value.
Rachel, Tom, thank you both for this fascinating debate. Let's wrap up with this. What's one thing you want viewers to take away from this discussion? Rachel, let's start with you.
Thanks, Max. For me, I'd say that understanding the world scientifically doesn't mean we stop questioning. Science is all about curiosity, but it's also about evidence and testing. My hope is that people will keep asking questions, but also trust the methods we use to find answers. The round Earth model is more than just theory. It's something that's been proven across time, by countless methods. It's okay to be curious, but it's important to base our beliefs on the best evidence we have.
Tom, what's your final takeaway for viewers?
For me, Max, it's about thinking for yourself. Don't take my word, or Rachel's, or anyone else's. Look around, do your own research, and see if what you experience aligns with what you're told. We live in a world where information is everywhere, and questioning the mainstream view doesn't mean we're anti-science. It means we're open to exploring all possibilities. I think that's what matters most.
Well, thank you, Rachel and Tom. Today's conversation shows us that questions about our world, even its very shape, bring out strong views, deep curiosity, and a lot of passion. Whether you're on the side of science, curiosity, or somewhere in between, we hope this debate has given you something to think about. Thanks for watching, and remember, stay curious.